Welcome to Chemistry Kitchen, where science and cooking come together. For today's video, we will be looking at acids and bases in cooking. And to do that, we will be cooking a key lime pie. Alright, so right now, Vishy is currently grating a lime in order to get some lime zest. As in this recipe, we're going to need 2 teaspoons of lime zest. And you can see here, we're getting ready to get some egg yolk. So we're preparing 2 bowls here. One bowl is going to be to hold the egg white, and the other bowl is going to hold the egg yolk. So we're going to have to separate the yolk and the white. So I'm going to crack the first egg here, and it's going to crack open. Almost failed that, but some of that egg white is coming out, and now we're just going to do some masterful cooking skills and separate the yolk out. Get as much of that egg white off as possible. Alright, nice. Yeah, that's really satisfying. Alright, put that in. And now we're just gonna repeat the same process for 2 more eggs, and we're gonna have Sol do one of them and Kyle do one of them, and we're just gonna speed this up so you can watch it faster. Alright, and now we have our yolks. We're about to pour the yolks into the tube right there. So now we have those 3 yolks at the bottom of the mixing tube. And now for this next step, before we can actually start mixing, we gotta actually, Sol points out, we gotta get the lime zest in there. So 2 teaspoons of lime zest. Vishy's hard work really helping us out here. Nice. So now we got 2 teaspoons of lime zest and 3 yolks in there. And we're gonna put this into the mixer, and we'll be back after it's all blended and ready for the next step. Alrighty, we just kind of went through a speed through there, a little time lapse, and now it's all mixed up. Those egg yolks plus zest are nice and mixed and fluffy, I guess. So now we're gonna go on to the next step here, which is essentially we're gonna pour in some condensed sweetened milk. Alrighty, so now we can see Kyle's got that lime juice in his hand right now, and he's just gonna squeeze it until get to the right line. And now inside our mixed condensed milk, we're gonna pour that lime juice in. And now that we got that in, we're just gonna seal the mixing cap, and we're just gonna mix it again. And I'll be back once that is done. Alrighty, so now we're just gonna pour that mixture into our pie crust pan. Alright, so after the first mixture we poured in, we realized that it wasn't really filling it up, so we repeated the process and got a second mixture, and now we're just getting that even in there. And just like that, it's nice and even, and we're all set and ready to go in the oven. Alright, and now we just throw it in the oven and wait for it to get ready. Alright, so honestly we had to cook it for a little bit longer than anticipated because we forgot that we added actually double the amount. But now, after cooking it for an extra maybe 12 minutes or so, we're ready to take the pie out. And wow, look at that, it's beautiful. Alright, so now that we're done with the cooking part, we're gonna move onto the science of what you just saw.
Thank you, Ryan. I'm currently at Merced in Washington at the sour facility. The sour taste is determined by its acidity. Some examples of sour foods include citric fruits, kimchi, and some soda berries. The biological implications of the sour taste includes the ability for tracking unripe fruits and keeping unwanted acids out of our bodies. In the late 1800s, scientists presumed that pH was the biggest indicator of sour taste. However, this was disproved by the organic versus mineral test, where organic acids such as acetic and citric acid was compared with HCl. They had the same pH, however, organic acids were considered to have a more sour taste. And towards the late 1920s, this was proved by H plus ions, free and undissociated, along with N ions, had an effect on the sour taste. Thank you for listening. And now let's move on to Vishy about the bitter taste.
Alright, thank you Sol for the information on acids. I will now talk a little bit about the bitter taste. Bitterness can be described as a sharp, pungent, or disagreeable flavor. Usually, foods that taste bitter have alkaloids, or a naturally occurring compound that contains at least one nitrogen atom. One of the most common examples of an alkaloid is coffee. One theory for why alkaloids tend to taste bitter is that many alkaloids are toxic, so in order to protect us from poisons, we get a bitter taste when we eat them. Another food that is considered bitter are some cruciferous vegetables, or vegetables like broccoli, Brussels sprouts, kale, and radishes. One reason why younger children are usually thought not to like these foods is that younger people tend to have more taste receptors, and as we grow older, the number of receptors that we have declines, so our response to that bitter flavor declines over time.
Vishy, I'll be going over two chemical processes that occur during our baking. First is the Maillard reaction. The Maillard reaction takes glucose and an amino acid to form glycosylamine, which then reacts to form varying products including pyrazines, pyrrols, alkylpyridines, acylpyridines, furanones, furans, oxazoles, and thiophenes. The second process is caramelization. This process takes sucrose, water, and heat to break it down into glucose and fructose. These sugars are then broken down into many products. Some of these products are acetic acid, furan, and maltol. Acetic acid typically gives a sour taste, furan gives a nutty taste, and maltol gives the typical caramel taste we all know.
Alright, thank you guys for watching today's video. That's gonna be all for today. And make sure you like, subscribe, do all that, and we'll see you in the next one.